All right, I started recording. So main takeaway, know how to find the y-intercept. Should already know based off of what we did Friday, but know what it represents. The rate, know where it's going faster, know where it's going slower, regardless if it's increasing or decreasing. Write the equation, know what the formula is, and also be able to predict other values, okay? So first things first, let's just go ahead and rewrite the formula because it's actually not written anywhere on here. What is the formula for an exponential function? X squared is quadratics. Nope. There's no H. H is quadratics. What'd you say, Alex? Nope. I mean, nobody's looking at their notes, apparently. What's up? A times B. And what's special about an exponential? It's in the word. It's in the word, exponent. Not squared, not plus. There's no plus signs. There's no squares. I'm gonna need you to stop. Hey, I'm gonna need everybody to stop guessing. Stop guessing, get your notes out. You have them for a reason, not to waste my time. To the power of X. The power of X is what makes this special. Your X value is the exponent. Your X value is the exponent. That X value represents what? It does not represent, once again, stop guessing. If you don't actually see it in the notes, then don't shout it out. It represents time. Thank you. Pretty sure everybody's going to enjoy listening to this video. So, all right, let's look at the very first example. The exponential function. Anytime you're given a graph or a table, you want to be looking for clues, keywords on knowing what it is, because believe it or not, people are going to see this graph and they're going to see a straight line. No, it's an exponential function. It is half of a curve. Is modeled below, represents the estimated growth of Stacy's family beginning with her great grandparents. Beginning, that means initial, the start, whatever. You're beginning, you're starting with the great grandparents, okay? So we're just going to complete the following statements and or answer the questions. A, it says the initial number of individuals in Stacy's family are, no shout out now an answer yet. What is initial? Initial represents your y-intercept on the graph, your initial value. What is the variable in the formula for the initial value? The variable for in the formula, it is A. Initial value is your value of A. And yes, it does represent your y-intercept on the graph if all you have is the graph to look at. Bless you. So we look at the graph, we see the y-intercept because it is actually given to us, but the initial value is which one? We talked about it on Friday. Value means your y value. Value means your y value. So 2, which makes sense. It says we start with the great grandparents. We start with just those 2 people. Okay. B, the number of, and that's where I forgot to include the number of family members. The number of family members, does it increase or does it decrease? Is my line going up or is it going down? It's increasing. As the years go by, as the generations go by, notice that the line is going up, means we're adding more people to the family. We're not dying off, we're actually growing. We are expanding. So increase, I'm gonna underline or highlight increase, circle it, do what you gotta do. At a rate. Rate is always given in percentage. Always keep that in mind. It increases at a rate of 100% each year. All right. It says write the function that best represents the relationship. I was accused of never telling anybody what a function means. I have. What does a function mean for those of you that actually remember? If it's asking you to write the function, it's asking you to write the equation. equation. What do you know, sixth period? I guess I did teach y'all that. So we have the value of A, and our formula is f of x equals A times B to the power of x. What are we missing? We already know what A is, so that means we're missing B. Now B is considered your what? Look at your notes. Correct. The B value is your factor. It's the multiple. I don't know why I wrote that twice, sorry. It's your factor, it's your multiplier. B is your factor. Your factor is not the same as your rate. Factor. One thing that you need to know, the rate is not the factor. The rate is not the factor. They're not the same thing. You use your rate to get your factor, or you can grab the rate from the factor. Now, the formula that we wrote in the notes day one was that the factor is either 1 plus or 1 minus the rate. Now, which one of these two values are we given? Are we given the rate or the factor? The rate, but they give it to us in what form? As a percent. So if I go from percent back to decimal, which way do I move that percent sign? 1, 2. And it gives us what? 1.0. Now, for those of us that have to do it using the calculator every time, which is fine, you take the percent and divide the 100. On Thursday, we practiced taking the percent and multiplying. But if you're going from percent back to decimal, you divide and it gives you 1. Now, because we are increasing, is that going to be 1 plus or 1 minus? 1 plus. We are increasing. Increasing means plus. Okay. Now 1 plus 1 is going to give us what? 2. So this is the number that goes into the equation. Factor, it goes into the equation. The factor goes in the equation. The rate is just telling us how fast we're going up, how fast we're going down. So what number do I put in the front? The number 2. My initial value goes in the front. A is the 2, the initial. And what goes in the parentheses? 2, the factor. The factor goes inside of the parentheses. So now we know how to find the initial number. We know about the factor and the rate. You can create your equation. Now let's start predicting. The number of individuals in Stacy's family at the end of what? 5 generations. Where do you see the word generations? On the X or the Y axis? It is your X axis. So that means we're looking at our X values. This is my X axis. This is my Y. My Y is talking about the growth size. So if it gives us 5 generations, if it gives us the X value, we're looking for the Y value. All right, let's go over to the 5. And if I go to the 5, I go straight up. What is the Y value? 64. So we will be 64 families or people by the end of the 5th generation. My bad, 64. 64 family members. Don't turn the page. Everybody got that? Questions on A through D? All right, now the next thing, the only other thing that you guys need to understand that you need to think about is the rate. Where is it increasing faster? Where is it increasing slower? Where is it decreasing faster? Where is it decreasing slower? So you have 2 types of graphs. One of them starts at the left and it goes up. The other one starts at the left and it goes down. Think about, the easiest one to think about here is the decreasing. If you're on a roller coaster or if you're on a slide, any regular slide, where are you going to go faster? In the beginning or at the end? In the beginning, you go faster. And as you get down to the bottom of the slide, you slow down till you come to a stop. It's the beginning where you see the fastest speed. Same thing with the roller coaster. You're going down fast and then you start to slow down. Some roller coasters go back up, so then you start to go up. But the down part is where you're going faster. That's one thing you need to understand, faster. And you start to slow down at the bottom. Now, I don't have a good example, like a visual, when it comes to increasing, except coronavirus, just because that's more relative to today's world. Let's say, how many people started off infected? Just one person. It had to all start with one person. That one person infected somebody else. Those two people infected another two. Those 4 people infected another 4. Those 8 people infected another 8. And then it started growing until it became a worldwide pandemic. So let's just say in terms of our classroom, let's say Ms. Ramirez starts as the one that's infected with coronavirus, and I infect Aiden. Now me and Aiden are going to infect Rolando and Chris. And now all 4 of us are going to get the next 4 of you. That would be a slow increase. But let's say all of us as a group are infected with coronavirus and we go infect a whole other classroom because there's so many of us. And if we infect another classroom, you're going to see a much larger gap. You're going to see a much faster increase. So same thing here. You start off slow, but at the top is where you see that faster increase. Same thing. What's up? Yeah. So look at the chart here where it says Stacy's family. The growth is slow because your family size is still small. You only started out with the great grandparents here at number 2. And then by the 2nd generation, you're still only at 8 people. But look over here, because you have so many more people, 64, by 2 generations more, you're already up to 256. It's a much faster increase. Everybody understand that? Think of a slide, okay? All right, now we can turn the page. Number 2. Jamal's bank account. Jamal's bank account is earning an annual compound interest that was open at and there was no additional deposits or withdrawals that were made after the initial deposit. The balance in the account after X amount of years can be modeled by this equation. Sometimes it will give you the equation in the word problem. It won't always. Use that to your advantage. You know this is important information. Got it? Let's look at the questions. The initial balance, initial value. Initial value is what variable? A, variable. Listen to the question, variable, A. Now, sometimes you can tell just by looking at the graph that this point starts at the number 100, but where else can I find it? Where else can I find that 100 in my word problem? Please do not pick up the calculator. We haven't done any calculations. Where do you see it on the equation? Right in front of the parentheses, right after the equal sign. There's my initial value. Mark that down. There's my initial value. If you cannot find it on the graph, you should be able to find it on the equation. They will give you the information one way or another, okay? So the initial balance in the account was 100. This is a y-intercept. That 100 is on the y-axis. What are we describing on the y-axis? Dollars. We're describing dollars. So it says the initial balance in the account was $100. Now, B part. B part is the part where everybody messes up, especially because I've asked you to start on that test review, 3B, 15B, 16C. They're asking specifically for the rate. It's not asking for the factor. Remember, the rate is a percentage. The rate is not, your factor is not the same as the rate. This equal sign with the slash through it means not equal to. The factor and the rate are not the same thing. You can use the rate to find the factor, or you can find the rate within the factor. In this case, what do they give us? They give us the factor. What is the factor? 1.04. There's my factor. I'm gonna put a little F right there. There's my factor. Once again, your factor is not the rate, because your rate has to be a percent. I don't see any percent signs, do you? No, so it's not the rate. But we can find the rate using this information. Ready? All right, so let's write that formula. 1 plus or minus the rate equals my factor every time. 1 plus or minus the rate equals my factor. Is this one increasing or decreasing? Increasing. So because it's increasing, we have to have a plus sign. Because it's increasing, we have that plus sign. Now, what is the factor once again? 1.04. What did we add to 1 to get 1.04? 0.04. Notice this is the one that we labeled as the rate. Now, because I have to have it as a percent, I take that 0.04 and move that decimal which way? To the right, 1, 2. And our rate is 4% each year. Always pay attention to what they're asking. Are they asking for the rate or are they asking for the factor? Ready? The balance in the account at the end of 10 years. Years is where? X or Y? X. So we're given the X value. That means we have to find the Y value. We're given the X, we find the Y. Go to the 10 years, go to your X value of 10. And then if I go to the side, it lines up with 150, 150. And notice it does say approximately. It does say approximately. It doesn't mean it's exactly 150. So you want to find something close. So I'm just going to write that word close to. That doesn't mean you're going to see 150. You might see 148. You might see 149. You might see 151. Find the one that's closest to the 150. How many years will it take for Jamal's balance to double? It's telling us that the balance, the dollar amount doubled. What does it mean to double something? What'd you say? Multiply times 2. Times 2. I had somebody tell me earlier that we add 2. No, double means to multiply. That's why I'm putting it in parentheses. Multiply times 2. Now, in order for me to multiply something times 2, I need to know what the initial balance is. I do know what it is. It's that 100. So 100 times 2 gives me, that means I need to find where we see the 200 and what is the X. My initial balance is 100. If we double that, it gives us 200. So I'm going to go to the 200 on my graph and see what year it gives me. I go to the 200 and I go straight across to this point and I go straight down, close to straight down, and it's 18 years. 18 years. Questions? 18 years. That's the answer, 18 years. All right. Number 3, each year, the local country club sponsors a tennis tournament. The tournament play starts with 128 participants. During each round, half of the players are eliminated. What is the initial amount? What's up? 128. Do you see that on the graph? No, you don't see it on the graph. On the graph, if I were just to look at the graph, I'd probably say 130. But if you can't, if you're finding yourself estimating, double check in the paragraph to make sure it's not already there. And it is. It says we start with 128. We start with 128. Start meaning initial value. What's my initial value? My value of A. We start with 128. So initial amount, my A, 128. All right. Now it says the number of participants decrease at a rate of, once again, we're looking for the rate. Rate is represented through percent, okay? So let's look in that paragraph. Do we see any percent signs there? No, so there is no rate here. We have to find the rate based on the factor. Now it does give us a word to help us find that factor. What word is that? half. It says half of the players are what? Eliminated. If they're eliminated, we're talking about decrease. Half. Let me move that up to here. So that is my factor. My factor is 1/2. We like to use decimals. So what is 1/2 as a decimal? 0.5. Everybody got that? Okay. I know what the factor is. My factor is 1/2 or 0.50. Once again, that's just the factor. My formula for the factor is 1 plus or minus the rate, because we're still looking for the rate. 1 plus or minus the rate gives us the factor. Fill in your factor because that's the part that you do know. Is it going to be 1 plus or 1 minus? Minus, because of the word decrease. We're decreasing, but you should also be able to notice on the graph that you are going down. Now, 1 minus what gives me 0.5? Or 1 minus what gives me 50 cents? Another 50 cents. But since it has to be in the form of a percent, 0.5, 1, 2, 50%. 50%. And I'm doing this every time, even though this 50% is easy, just because you won't always get such a pretty number. Got it? But we still know what the factor is. The factor is the one that goes into our equation. Factor is always the one that goes into the equation. So let's write, it says write the function, meaning write the equation. F of x equals a times b to the power of x. So f of x, what is the number after the equation? I mean, after the equal sign? And what number do we put in the parentheses? 0.5 or 0.50 to the power of x. Don't forget your power of x. Even though we haven't really used it yet, don't forget your power of x. That's what makes an exponential function special. Got it? All right. It says approximately. Once again, we're estimating, we're predicting, we're just guessing. We're using an educated guess, like you guys love to say. How many participants were left after what? Which round? The first round. The rounds are where? My x or my y axis? Rounds. Rounds are my x. So we're looking for the y value. Rounds are the x. We're looking for the y value. You see the x here at the bottom. This is my x axis. We're looking for the y value. It says the first round, so 1 round. We go straight up, and we can actually trace it back to somewhere in between 60 to 70. So we could say what? Approximately 65. So I'm going to use this little squiggle, the little squiggle. I don't know the actual term for it, but it represents approximating. It means around 65. E says, after how many rounds will there be 2 participants? The information given, participants, is that an X or a Y value? This is a Y value, meaning we're looking for the X. We're looking for the X. Now, this is talking about a very specific number, and a lot of people go straight to either the 6 or the 7 because that's at the very bottom. But we are given enough information to find the exact value. This is it. Ready? So we started with 128 players, and they're eliminating by how many? Half. So you should know how to find half of 128. What is half of 128? 64. So our approximation, our 65 is close to 64. We did good. Half of 64? 32. Half of 32? Half of 16? Half? A half? And half. 1. So after how many rounds will there be 2 people left? 6. There's my final round. 2 participants. 2 participants. Now, final question. Will there be an 8th round? Yes or no? Why not? Correct. There's only one participant left after the 7th. You cannot have half of a person. There's always that one person that wants to get technical talking about amputees. Don't do it. You cannot have half of a person, period. All right. So the answer is not. And the explanation, I want to see that explanation in your notes. Tournament ends on 7th, Aiden, write this down, round with 1 player left. The tournament ends on the 7th round with 1 player left. You might have an answer choice that asks you that. When does the tournament end? The tournament ends on the 7th round with 1 player left. Turn the page when you're ready. Today is all about knowing the meaning behind all the numbers. All right, as you're turning the page, number 4, in 1985, there are 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year. After 1985, the data can be modeled by an exponential function. Here we go. What is the initial amount of cell phone subscribers? So initial, once again, initial value. Your initial value is what variable? A, initial value. A. Now, could you get the initial value just based off of the graph?
Oh,
No, it's jumping by how many? 200s. And if that point is in between 200 and 400, I'd probably guess 3, but that's not even close. You have to look at the paragraph as well, and you will see it says that there were 285 cell phone subscribers. So that's my initial value. If you can't find it on the graph, find it in the paragraph. So 285. Okay. The number of cell phone subscribers increase at what rate? Can you tell what the rate is just by looking at the graph? But it does give us a percentage in the paragraph. What is it? 75%. Notice that percent symbol. Now you can say that that is the rate, 100%. That's the rate because it has that percent symbol in there. So let's write that down, 75. Now, in order to find the factor, I need the rate. I can't write my equation, my function. I can't do part C without finding the factor first. And you find the factor by taking the 1, either adding or subtracting the rate. I know that it's 75%. How do you switch 75% to a decimal? Go back to 1, 2. So it's 0.75. Now, because we're increasing, do I put a plus or a minus? Plus. And 1.75 gives us what as the factor? 1.75. That's the number that goes in the parentheses. That's why I have it there. That's my value of B, in case you forget. Now we can write the equation. We can write the function. So f of x equals A. You don't have to write the equation every single time on your assignment, but you do on the notes. F of x equals. So what number goes right after the equal sign? 285. What number goes in the parentheses? And what can I not forget because this is an exponential function? X is your exponent. X is your exponent. Exponential. Okay. D, how many cell phone subscribers were there in 1987? 1987 is a what? It's a year, and your years are where? X or Y? X axis. It's on the X axis. So that means we're looking for the Y value. We're given the X value. We're looking for the Y value. You see the word years right there? That's your X value. Now, I can't, this graph doesn't go all the way to 1987. Why not? It starts at 1985. It says that it's years since 1985. So the 0 represents the year 85. The 1 represents what year? And the 2 represents, so we're actually supposed to go to the number 2 and estimate, approximate, predict how many cell phone subscribers, and that's between 800 and 1,000. What number is between 800 and 1,000? 900. So if you're given 4 different answer choices, find the one closest to 900. So approximately, squiggly, approximately 900. Okay. It says, in what year will there be approximately 2,700 cell phone subscribers? 2,700 is a X or Y value. This one is a Y value. Okay. So let me go back up. You find the 27 in between 26 and 28. So I'm going to go straight across from there. And that one lines up with what number? 4. Now I'm going to have about 50% of you on the STAR test bubble in the number 4. Is that correct? This is not describing the year 4. We stopped at 87. Let's keep going. 88, 89, 1989, 1989. Don't jump the gun just because you see a number. Figure out, am I writing the correct number? Should I be writing the 4? Should I be writing something else? So the year 1989. Questions? All right, next one. William takes 500 milligrams of ibuprofen for his headache. Every hour, half of the medication is absorbed into his body and can best be modeled by the what? Exponential function. Underline it. Exponential function graphed on the grid below. A, what was the initial amount? 500. Can you find it? Initial, once again, is your value of A. Can you find it on the graph? Yep. Can you find it in the paragraph? Also. Found it on the graph right here. My initial value, my initial Y value is 500. But it says he takes 500 milligrams. He takes 500 milligrams. That's my initial value. All right. Part B. The amount of medication absorbed in the body indicated an increase or a decrease. It's a decrease. You can tell it's decreasing because you have a graph that's going down, but it's also being absorbed. It's being absorbed. That means the medication is going away. He's using it, whatever you want to think about, whichever way you want to think about it. It decreases at a rate. Do you see any number in there with a percent sign? No, but you do see a number that helps you with the factor. What number or what word, whatever. What is that? It says the word half. It says the word half. And 1/2, it doesn't have a percent. So 1/2 represents my factor, represents the factor. We can use that factor. Get your head up. We can use that factor and we use our formula. 1 plus or minus the rate equals the factor. 1 plus or minus the rate equals the factor. Am I going to have a plus or a minus? Minus because it's decrease. All right. Now my factor is 0.5. What is the rate? Also 0.5. Now my rate has to be in the form of a percent. So I'm going to take that 0.5 and move it 2 to the back so I can switch it to a percent, and it's 50%. The factor is 0.5. It says write a function. Once again, f of x equals a times b to the power of x. F of x equals, what is my initial value? What number goes right after the equal sign? 500. What goes in the parentheses? 0.5 or 50 to the power of x. After how many hours is half of the medication? This is the number we're given, half of the medication. In order to know what half is, we need to know the initial value. We started with 500 milligrams. What's half of that 500? 250 milligrams. 250 milligrams is my Y value, so we're looking for the X. We're looking for the X value. So let's go to that 250. And after how many hours? 1. My Y value, X value is 1. After 1 hour. Says, how much medication will there be left after 9 hours? 9 hours is an X or a Y value? X. So we're looking for the Y value. And what does it give you at 9 hours? 0.98. 0.98. Turn the page when you are ready. This is my 9 hours. All right, the last two are multiple choice. So here we go. The graph below shows the relationship of an insect population over time. According to the graph, which of the following statements appears to be true? We're looking for a true statement, not a false. Sometimes it will, so you need to be careful. A, it says the insect population increased. Increase means to add by 4 each day. Now, if it gives you a specific number, if it says we're increasing by 4, that means to add. If you're increasing with, and it also gives you the number, so with the number, that means to add. If you see the word increase in general without a number, increase or decrease in general, meaning they don't give you a specific number, then it's talking about an exponential function. Exponential. So let's look at what happens if we increase 4 each day. We start with 2, and I better see these lines. We start with 2, and 2 plus 4 gives us what? 6. So the first 2 points line up. We're so far so good. 6 plus 4 gives us 6 plus 4, 10. 10 plus 4 gives us 14. And then 14 plus 4. So what happened because we were increasing, because we were adding 4 each day? We ended up with what? A straight line. If you're going to add the same amount every time, you will end up with a straight line. Just like we talked about earning dollars every hour. Look at, so it cannot be A. Look at B. Once again, increase. It could be exponential, but they give us a number. They give us a specific number. So we're adding 3. So let's do the next one. 2, if you add 3, what do you get? 2 plus 3 is 5. So we should be between the 4 and the 6. 5 plus 3 is, man, we forgot how to add. 5 plus 3 is 8. 8 plus 3 is 11, between 10 and 12. 11 plus 3 is 14. Right there. So once again, when you add, you end up with the straight line, and that is not what we're working with today. I need to see 2 straight lines on that note, on those notes. So not A, not B. Remember talking about that roller coaster? That's where your C and D come in. C says that there was more increase between day 1 and 2. D says there was more increase between day 2 and 3. So we're going to look at the increase in both days. Day 2 is right here. So I need to see what happened between day 1 and day 2. There's my increase. Day 1 to day 2. The other one says that the biggest increase was from day 2 to day 3. Which one has the larger gap? Day 2, day 3. So my answer is D. Next one. Ready? D. All right, last one. The weekend of the premiere of the new Batman movie, the film brought in 100 million's worth of revenue, the exponential, underline exponential, and there's your equation. So it says, which one of these statements is true? Same thing. It says the film's revenue increase means add by what? 100 million. It gives us a number, so we're adding. Did it increase anyway? No. Look at C. It says the decrease subtracted by 100 million each weekend. Are we subtracting 100 million every single weekend? No, no, we didn't give a straight line. If it says increase with a number or decrease with the number, straight line. This is not a straight line. B and C, it says it starts at 100 million, but the difference is in the 40 and the 60%. That part is what's going to trick everybody every single time. So underline the 60 and the 40%, and let's figure this out real quick. Ready? We know that it's decreasing. Do you have anything in here that gives you an actual percent sign? No, but we can use this 0.6. Once again, does not automatically mean that my answer is B. You know that 1 plus or minus the rate is the factor. So the 0.6, is that the rate or the factor? This is the factor, 0.6. This one's the one in the equation. The rate is my percent. Now, since we're decreasing, we subtracted. What did we subtract to get to 0.6? 0.4. That's the one that you want to switch or change to a, why are you putting your things up? That's the one you switch to a percent and you get 40%. So your actual answer is which one? D. Don't let one like this trick you. Know the difference between a factor and a rate. Rate is always in percent.